Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through the basics of trigonometry. So trigonometry involves right-angled triangles and finding unknown sides and angles. So unlike Pythagoras, which is where you have two unknown sides and you find the third side, trigonometry involves angles. So I'm just going to label another angle here, theta. So it's important in order to find sides and angles that we label the sides appropriately. So just as in Pythagoras, the hypotenuse, which I call hype for short, is always the longest side, always the one that is facing the right angle. So we need to label the other two sides as well. So the other side that is touching angle theta, we call that the side adjacent to theta. I'll call ADJ for short. And the side facing theta, we call the opposite, okay? So the hypotenuse is the same in any right-angled triangle. It's always the longest side. Let's take another right-angled triangle, right angle here. So this time I'm going to label a different angle. So I'm going to call this one here beta. So as I said, the hypotenuse stays the same in any right-angled triangle. It's always the longest side opposite the right angle. But the opposite and adjacent switch around depending on which angle you're referring to. So now it will be this side here that is the adjacent because it is the side touching the angle I'm talking about, in this case beta. And this side would be the opposite because it's facing angle beta. Really important that we get these sides labeled the right way around. So there are three ratios that we need to know in trigonometry. So the first is called the sine ratio. So we call it sine of an angle. Doesn't matter whether I put a theta or a beta there or whatever. The cosine ratio, which we call cos for short, and the tangent ratio, which we call tan for short. So the sine ratio is the ratio of O over H opposite to hypotenuse, cos is adjacent over hypotenuse, and tan opposite over adjacent. You just have to remember these ratios. So the acronym to remember is SOHCAHTOA, so that means sine opposite over hypotenuse, cos adjacent over hypotenuse, and tan opposite over adjacent. So you really need to know this in order to do any trigonometry. So the thing is, if I have a right-angled triangle and I fix the angle theta or beta or whatever, so too are these three ratios fixed. So let's say I tell you that this angle here, theta, is equal to 30 degrees. Now, if I put sine 30 on my calculator, so make sure your calculator's in degrees, you should get sine 30 is equal to a half. So what does that mean? Well, sine is the ratio of the opposite to the hypotenuse. So sine 30 equals a half means that the opposite side is half of the hypotenuse. So if this angle here is 30 degrees, it means this side is half the length of this side. So if the opposite side was 4, the hypotenuse would be 8. If the hypotenuse was 12, the opposite would be half that, it would be 6. So that's how we use these three ratios to find unknown sides and angles. So let's look at an example of this. So let's see how we would now use this information to find unknown sides. So I'm going to find the value of the pronumeral in each of these triangles. So your first step always needs to be to determine which ratio you're going to use. So here I have an angle and I have another side. So I can find any other side in the triangle. So this side 10 is opposite the marked angle 45 degrees, and this side here is the hypotenuse. This question involves the opposite and the hypotenuse. So our acronym was SOHCAHTOA. So I go to that acronym. Which one involves opposite and hypotenuse? It's this one here. The S stands for sine. So we are going to use the sine ratio. So we set up our equation. Sine of theta, sine of the angle, equals opposite over hypotenuse. So because O comes first here in the acronym, O goes on top. Opposite on top, hypotenuse on the bottom. In the second triangle, this side here is the adjacent, and we also have the hypotenuse. So which one involves adjacent and hypotenuse? That's this one here, the cosine ratio. So this would be cos of the angle 60 degrees equals adjacent over hypotenuse. So once again, because A is listed first here, the adjacent goes on top. So now we just have to solve these equations. The way we solve them is slightly differently, so make sure you're paying attention. When the thing you want to find is on the bottom, you divide. So here, to get x by itself, x would be 10 divided by sine 45. Okay, sine 45 is just a number, and you can put this straight on your calculator. So when the thing you want to find is on the bottom, you divide, but when it's on the top of the fraction, you times. So here it wouldn't be y is 74 divide cos 60, it's y equals 74 times cos 60. So you must make sure you understand this. When the thing you want to find is on the bottom, you divide. When it's on the top, you times. So we can put these in our calculator. So if I put 10 divided by 40 sine 45 in my calculator, I should get about 14.14, and it goes on forever. So I'm just rounding it to 2 decimal places, okay? So if you put 10 over sine 45 in your calculator and got a different answer, you're probably not in degrees mode. You need to see this at the top of your calculator. You need to be in degrees mode, not radians. So that's the first answer. Now in the second triangle, I could put 74 cos 60 on my calculator and I'll get exactly 37. So sometimes you get a whole number. Most of the time you get something like that. You don't get a whole number. Usually you get an irrational number. So that's how we find unknown sides using trigonometry. It's pretty simple. Choose which ratio to use, set up the equation. If the thing you want to find is on the bottom, divide, and if it's on the top, you times. All right, let's look at how we would use trigonometry to find an unknown angle. So let's look at this diagram here. So what makes this different than the previous two diagrams is that now I know the value of two sides, but the pronumeral here, theta, is actually an angle. So I'm actually trying to find the value of an angle. So the way I do this is very similar to what I just did. I need to choose which ratio to use. So 3 is the side opposite theta, it's facing theta, so that's the opposite. And 4 is the side touching theta, it is the adjacent. So I have the opposite and adjacent. So if I go to my acronym SOHCAHTOA, it's this one that has opposite and adjacent. This one involves tan. So the way I set up my equation is actually the same as when finding a side. So tan of the angle equals opposite over adjacent, like that. So the difference here is I don't have the unknown in the fraction. The unknown's here. So I want to get theta by itself. There's a way I can undo taking the tan of it, and it's called the tan inverse. On most calculators, you have to press shift and tan, and it looks like this. So what I actually am essentially doing is taking the tan inverse of both sides. So take the tan inverse of the left-hand side, and I'll take the tan inverse of the right-hand side. So tan inverse and tan undo each other, and I'm just left with theta equals tan inverse of 3 over 4. So you can put this on your calculator. You press shift tan and then 3 over 4, and you should get about 36.9 degrees. That's to 1 decimal place, okay? If you got something different, you're probably not in degrees mode. So what actually happens is you use sine, cos, and tan like I did on the previous slide. You use them when you're finding a side. But when you're finding an angle, you go to sine inverse, cos inverse, or tan inverse. That's for an angle. Now, when you're finding an angle, you don't need to go through all of this. I was just showing you why it works. You can just go straight to theta equals, okay, this is a tan question, but I want to find an angle, so it's tan inverse, and it'll be opposite over adjacent. You can go straight to that, putting that in your calculator to save yourself some time. And you should get 36.9 degrees. All right, now we're just going to try a question that's a little more challenging. So let's have a look at this question here. Base of an isosceles triangle, 12 centimeters, two angles equal to 70 degrees, and we're going to find its perimeter. So you might be thinking, hang on a minute, this isn't a right-angled triangle. Well, whenever you're given some information like this, worded information, turn it into a diagram, and then we'll see what we can do with right-angled triangles. So let's draw the triangle. So isosceles means two equal sides. So the base is 12 centimeters. So two angles equal to 70 degrees. The equal angles in an isosceles triangle are always these at the base, where each equal side meets the base. Okay? So this is not a right-angled triangle. None of the angles are equal to 90 degrees. But if the triangle is isosceles or equilateral, what you can do is divide it into two congruent right-angled triangles. So each of these two right-angled triangles will be the same size and everything. So that means that this side here will be 6 centimeters, half of 12, and this will be 6 centimeters. So I can now find what this side, what its length would be. So I'm going to call it x. So now I'm looking in this right-angled triangle. I'm just going to use trigonometry like I did in the other questions. So first, which ratio? So I have the adjacent and hypotenuse, so that's cos. Cos of the angle equals adjacent over hypotenuse, okay? So now that we've got that, we want to solve it, and we can solve it in one step. So the issue here, x is the thing we're trying to find, and it is on the bottom of the equation. So when it's on the bottom, we want to divide. So x is going to be not 6 times cos 70, 6 divided by cos 70. Now, before we put this in our calculator, I just want us to have a think about what the answer should look like. Now, I don't expect anyone can do 6 divide cos 70 in their head. But we should be thinking x is the hypotenuse, so the answer I get has to be more than 6, and probably be a lot more than 6, okay? If I got an answer under 6, I've done something wrong, and probably I have times when I should have divided, or vice versa. So if I put this on my calculator, I end up getting to 2 decimal places, about 17.54. So that is the length of the hypotenuse of that right-angled triangle, but that's not the answer to the question. The question was, what is the perimeter? So the perimeter is going to be the base plus 2 lots of those equal sides of 17.54, which gives us 47.08 centimeters, okay? So the idea here, when you're finding an unknown side or angle, determine which ratio, set up your equation, and solve. If you're finding a side, you use sine, cos, or tan. Remember, if the thing you want to find is on the bottom, you divide. If it's on the top, you times. If you want to find an angle, however, you use sine inverse, cos inverse, or tan inverse. And please make sure you see this symbol at the top of your, or at least the black Casio calculators, to make sure you're in degrees. Alright, sorry for the long video. Thank you so much for watching. This has been the luckiest maths teacher in the world. Have a great day.